We're starting a new unit on Triangle Trig. We're going to spend a lot of time exploring how to work with triangles that are obtuse or acute. Before we do, however, let's review what you already know about right triangles, and then let's continue to use these ideas throughout the rest of the chapter. I'm going to set up these problems and let you finish them on your calculator in order to save time in this video. So I need to solve for x. The deal is I cannot solve for x as it's currently written. I'm going to need to add a variable. So I'll choose to add the variable a here, and then let me call the entire base of the triangle a plus 40 or 40 plus a. I could have also called the entire base of the triangle b and called the piece that I labeled a b minus 40. That would have also been an option. Just be clear in your labeling. So now when I look at it, I notice on the small right triangle that contains the 51-degree angle, I could say that tangent of 51 degrees equals x over a. But I can't solve a single equation with two variables. So I need to find another triangle trig statement I can set up that allows me to solve for a automatically, or gives me a way to solve a system with two equations with x and a both. Well, when I look at the large right triangle that contains the 43-degree angle, I can say that tangent of 43 degrees equals x over a plus 40. So this second equation does not allow me to solve for a by itself, but it does allow me to solve a system of equations with x and a both. So let me cross multiply on both and say that x equals a times the tangent of 51 and x equals a plus 40 times the tangent of 43. Now the idea I'm going to use is that if x equals a tan 51 and x equals a plus 40 tan 43, that those two a expressions must equal each other. So I'm going to say a tan 51 equals a plus 40 tan 43. At this point, I need to distribute. If you wanted to cut straight to this step, that is a-okay. If you wanted to skip the first step and go straight to the second step, that would have been fine. Now, I notice that I need to solve for a. I have two terms with a in them. So what I want to do is I want to bring the two a terms to the same side of the equation and leave the non-a term on the side by itself. At this point, and you've seen me do this before, we did this a lot in the exponentials and logs chapter, you need to factor a out of the left-hand side. That's the way you go from having two a's to a single a, which then becomes solvable. Then all you have to do is say, all right, let's divide. So you get this really messy expression that you can insert in your calculator. Now, I'm going to suggest that you're going to work the fastest and with the least round-off error if you'll only pick up your calculator once. Well, how would you do that? Well, if you look back, I need to find x ultimately. You've got two expressions that have x equals. I think this is the easier of the two. So all I would have to say is, let me say that x equals my a value, which is 40 tan 43, over tan 51 minus tan 43, and multiply that by tan 51. So now you've got x equals a tan 51 with all numbers. Then you are ready to finish this problem on your calculator with one step only, round to 3 decimal places, and make sure, or rounding to 2 decimal places is fine, make sure that you are in degree mode. So I'm going to let you do the calculator work, and that'll make the video you're watching go by more quickly. All right, so on this one, it's going to be kind of the same thing. I have to start out and say, I need to add a variable. I think that my preference is to add my extra variable here. And then I can call this whole side x plus b. You could have called the whole entire side a different letter and then called the segment that I called b a difference of the big minus the little. All right, so I'm going to start out again and say, well, in the lower triangle that contains the 28-degree angle, I'm going to say tangent of 28 equals b over 500. Oh, I like that because I can get b immediately. But to save time and round off error, I'm not going to use my calculator yet. I'm going to wait. Now, I ultimately wanted x. Well, if I look at the large right triangle that contains the 43-degree angle, I can say that tangent 43 is x plus b over 500. X plus b equals 500 tan 43. So x is what I want ultimately, 500 tan 43 minus b. Well, you know b. So let's insert it. X equals 500 tan 43 minus 500 tan 28. And you are ready to use your calculator to finish this problem in decimal form. Notice both problems required that I add a variable. Both required me to set up two right triangle trig relationships. The first problem required me to do a lot more algebra and solve a system. The second problem allowed me to not solve for the variables simultaneously, but sequentially. I could get b and then simply plug in to get x. You just never know when you look at a problem whether it's going to be one that's sequential or simultaneous. You just set them up, figure out what's going on, and then deal with whatever algebra comes your way. Now, when I look at this, I do need to mark that these are right triangles. I am personally going to say that the 40-degree angle here and the 43-degree angle I just drew in, they're alternate interior angles between parallel lines, so they're congruent. I could have also said, of course, that this is a 50-degree angle because the 40 and the 50 make a 90-degree angle. This is 34 also. I'm dealing with alternate interior angles. Let's see here. 90 minus 34, I believe, is 56 degrees. Now, I am allowed, when I'm trying to solve for x, to use either the 40 and the 34 or the 50 and the 56. It's just whatever floats your boat. On this one, I think what I need to do is let me call this c, and I'm going to call this x minus c. So I think I need to add some variables again. So when I look at the left-hand right triangle, I think I'm going to use the 50, and I'm going to say that tangent 50 equals c over 200. So c equals 200 tan 50. This is really a pretty easy problem. When I look at the right triangle, I'm going to say that tangent 56 equals x minus c over 200. So x minus c equals 200 tan 56. So this problem is more similar to example 2 than to example 1 because the algebra is so much easier. So let me go ahead and say that 200 tan 56 plus c means that x is going to be 200 tan 56 plus 200 tan 50. And if you had chosen to have said that tangent of 40 equals 200 over c and used the 40 and the 34-degree angles, you would have gotten a result real similar. You can always make that choice. So all that's left for you to do is the calculation. We'll move on to save you time. Now on this one, I'm going to label the bottom of the triangle in a similar way. Let me call this D and this 300 minus D. You can add if you want to, and I can say that this is a 43-degree angle in the left right-hand triangle. And let's see, what would that be? 36 in the right-hand triangle. I'm double checking my arithmetic right now. I think I've done those correctly. So I'm going to start out the same way and say that the tangent of 43 degrees equals d over x. Well, that's no fun because I can't solve for d or x. Let's see, in the right-hand right triangle, the tangent of 36 equals 300 minus d over x. Okay, well, this one's going to be more similar to example 1 because I'm going to have to solve a system of equations. So let me cross multiply and say that d equals x tan 43 and that 300 minus d equals x tan 36. So 300 minus x tan 36 equals d. If you're wondering why I did that, because I'm thinking if d equals this and d equals that, then I'm just going to set this equal to that. So I'm just going to say that x tan 43 is equal to 300 minus x tan 36. And x is what I'm wanting to solve for, so as soon as I isolate x, I'll have my answer. So I need to group all my x terms on one side of the equation, leaving my non-x term on the other side of the equation. I need to factor x out. And now I simply need to divide. So I've gotten the problem calculator ready. All you need to do at this point is run your calculator the one time. The less often that you run your calculator, the more quickly you're going to work through these problems. And the added bonus is that your answers will be more accurate. Once again, if I had wanted to use the 47-degree angle and the 54-degree angle instead of the 43 and 36-degree angles, I could have, and it would have worked out very, very similarly. Oh, we're going to solve without a calculator. So let's see. A watchman in a watchtower 130 feet above sea level spots the ship of Blackbeard the pirate and of Long John Silver. Okay, so I know that the watchtower is 130 feet and that we've got two ships out to sea. And so let's see here. I've got angles of depression of 15 degrees and 22.5 degrees. Here's what I know. The smaller angle of depression is 15 degrees and the alternate interior angle's out here. The larger angle of depression is 22.5 degrees and the alternate interior angle is here. Judging from that, if Blackbeard is spotted at an angle of depression of 15 degrees, then this must be Blackbeard way out here. And then Long John Silver must be actually closer to the lighthouse. Okay, so how far apart are the two pirate ships? So what I ultimately need is X. So what I think I'm going to do in this case is I'm going to say that's X, and then let me say that this is Y. And then if I need to, I can call this Y minus X. Okay, so let's see how we're going to handle this. I'm going to say that the tangent on the inside right triangle, the tangent of 22.5 is equal to 130 over Y minus X. And the tangent of 15 degrees in this large right triangle is 130 over Y. Okay, I'm going to clean those up a little bit. And I know that y minus x is the same thing as 130 over tan 22.5. And that y is equal to 130 over tangent 15. So using those, what I know is that if y minus x equals 130 over tan 22.5, that y minus 130 over tangent 22.5 is equal to x. So in other words, what I've got to actually calculate when it's all said and done is that x is going to be 130 over tan 15 minus 130 over tangent 22.5. Well, that causes me to have to stop. If I'm supposed to do this without a calculator, what I need to do is calculate tangent 22.5 and tangent 15. So let's do tangent 15 first. Tangent's always easier to do with your half angle formulas. So tangent of 1/2 theta is 1 minus cosine theta over sine theta. And in this case, of course, theta is 30. So cosine of 30 degrees is the square root of 3 over 2, while sine of 30 is a half. If I flip and multiply, it's 2 over 1 times 1 minus the square root of 3 over 2. When I distribute, I get 2 minus the square root of 3. I'll go back and insert that momentarily. I'm going to do tangent of 22.5 similarly. I'm going to make that tangent of 45 over 2. I'm going to make that 1 minus cosine 45 over sine 45. Now, you do not have to do this, but I have found if you don't rationalize the sine and cosine values, that it's easier, remember, to say, well, I need to multiply the top by the reciprocal of the bottom, and it's easier to do the reciprocal of 1 over the square root of 2. So then when you distribute, you're going to have the square root of 2 minus 1. It's just easier to work out, just a little trick. So let's go back and see what happens. I need to say that x equals 130 over, I've already forgot my value, 2 minus the square root of 3. And then minus 130 over tangent 22.5 was square root of 2 minus 1. Now you might say, why is she leaving those crazy spaces? It's because I know that I need to multiply by the conjugate on each of them in order to get them cleaned up. So that's why I'm leaving the spaces to just pound through the algebra. So let's see where that takes us. X equals 130 times 2 on the top is 260. 130 times the square root of 3. On the bottom, a squared minus b squared is simply 4 minus 3. So the bottom's just 1, which is nice. When I distribute the negative 130, I am going to act like I'm distributing a negative. I'm going to get negative 130 square root 2, negative 130. The bottom is a squared minus b squared is also 1. So you can essentially ignore the bottom and just combine those numerators, because the bottom just sort of goes out anyway. So I'm going to say 260 minus 130 is 130, plus 130 square root 3, minus 130 square root 2, and there's your answer without the use of a calculator, and that would be feet. So the two pirate ships are that many feet apart. Now, I'm going to switch over and remind you about how to find the area of triangles in order to develop a brand new area formula that's really quick and really handy. So traditionally what I would say to do is start with your area formula, area equals 1/2 base times height. And I'm going to do that with all of these. Well, when I look at this one, just remember, if you have a right triangle, even though the white triangle is not sitting in this format, the legs of the right triangle are the base and the height. So I'm just going to say 815 here. So area equals half of 8, which is 4. 4 times 15 is 60. No units, so I don't have to do anything there. On the blue triangle, I can either approach it by dropping an altitude. Drop the altitude in white. I can drop the altitude and says, okay, the base gets divided into 2, 2. Then I could divide it into 2 30, 60, 90 triangles. Or I can simply use the Pythagorean theorem and say h squared plus 2 squared equals 4 squared. I'm just using Pythagorean theorem. So h squared equals 16 minus 4, which is 12. So h equals the square root of 12, which of course 4 times 3 would be 2 square root 3. I can do it that way as well. Now, going back to area equals 1/2 base times height, I'm ready to insert. Base in this case would be 4. The height we just found is 2 square root 3. So half of 8 square root 3 is 4 square root 3, whatever the units are, squared. So I'm going to do the next problem in a similar way. I'm going to go ahead on the isosceles triangle and drop the height. Since it's isosceles, I know I divided up into 5 and 5. Oh, great. I notice that I've got a 5, 12, 13 right triangle, which means my height is 12 and I don't need to do any work. So when I go to area equals 1/2 base times height, the base is 10. The height I just figured out was 12. Half of 120 is 60. Again, units squared. So that's just an overview of using 1/2 base times height for area. Now, we're going to do the same thing here, and then I'm going to show you how you do it faster. So if you drop the height here, I'm going to say, well, to find the height, let me say that the sine of 50 degrees equals h over 9. So h equals 9 sine 50. From there, using area equals 1/2 base times height, the area equals 1/2 the base, which is 20, and the height, which is 9 sine 50. And then you could calculate your area. And you know what I want to do? Because I'm using A as one of the letters in the triangle, let me actually write out area equals to be specific. And you use your calculator and finish it up. Let me show you a different way that you can look at this so that you don't have to drop the height and do all that separately. If you look at what I gave you without adding extra labels, I have 29 and 50. All right, the first thing for you to notice is that you're given the information in the order side angle side. If you ever have side angle side, then this new area formula works well for you. So the area equals, the 1/2 here is part of the area formula that you need to memorize. The 20 here is the same thing as side little a on the triangle. The 9 sine 50 that you see here, well, the 9 is side little b on the triangle. And the 50 degrees is capital C. So for the triangle ABC, you can just use area equals 1/2 AB sine C. You might also, depending on if you had sides A and C, then you would need angle B here. Or if you had sides B and C, then you would need angle A there. But those are 3 quick area versions of the same area formula. So if you've got side angle side, it's faster than dropping the height, finding the length of the altitude, and using the area equals 1/2 base times height formula. I just did this on the previous page, 1/2 AB sine C, or 1/2 BC sine A, or 1/2 AC sine B. Those would be the only 3 opportunities to use the side angle side formula for area. All right, so we'll do this last problem without a calculator and go from here. So I'm going to say on this one, since I've got side angle side, I can go straight to area equals 1/2. The two sides I have are 10 and 6 times the sine of the included angle, which is 105. All right, well, half of 10 is 5. 5 times 6 is 30. And to do sine of 105 without a calculator, let me break it into the sum and difference formula, sum specifically, 60 plus 45. So I know that that's going to be sine 60 cosine 45 plus sine 45 cosine 60. Well, sine 60 is the square root of 3 over 2. Cosine 45 is the square root of 2 over 2. Sine 45 is the square root of 2 over 2. And cosine 60 is 1/2. So I've got 30 times the square root of 6 plus the square root of 2 all over 4. The only thing I can do is reduce and say, well, 2 goes into 30, 2 goes into 4. That's the only thing I can do to clean up the answer. I'm going to distribute the 15, and I'll have 15 square root 6 plus 15 square root 2 all over 2. So I'll throw in a couple of problems on your test that are no calculator. They'll be of that order. You've seen 2 no calculator problems. So you're ready to roll, guys. Thanks for watching, and I hope you have a super easy time finishing A56.